Hello everyone, welcome to Aryan tutorials on engineering mechanics. So in this video we are going to discuss about how to find out the moment of inertia of SMA circular section. So in the previous video already we have discussed how to derive an equation for the moment of inertia of a circular section. So in this video we are going to discuss about moment of inertia of semicircle. So already we know that the formula will be as the moment of inertia of semicircle about its center of gravity ig is equal to 0.11 or power 4. So how it is obtained, now we are going to discuss. Okay, the formula, remember the formula for moment of inertia of a semicircular section, a semicircular figure is a semicircular plane area is 0.11 or power 4, which is the radius of the semicircle. So how it is obtained, let us discuss now. So first I would like to take a circle which is of a particular diameter, okay, and assume the center point represents the center of gravity of this plane figure, which is a circular section. And as per the derivation for the moment of inertia of the circle, already we know the formula, that is moment of inertia of a circle about its center, which is the center of gravity, is pi d power 4 by 64. Okay, this is the formula we got for the moment of inertia of the circular section. So when you consider the moment of inertia of semicircle, half of the circle, with respect to the same center of gravity, that is g, which is on the base of the semicircle. Okay, so that means here about the same center of gravity of the circle, we can write the moment of inertia of the semicircular section as half of the moment of inertia of the circle here. Okay, about the same g point, that is the center of gravity of this circular section, we are writing the moment of inertia of the half of the circle. So that is half of the moment of inertia of the circular section, which is about the center of gravity, which is on the base of the semicircle. So assume AB is the base of the semicircle. So above AB line, we can consider this part as the semicircle. So this semicircular section, for this semicircular section, the moment of inertia of this semicircular section about this G point, that means about its baseline, is equal to half of the moment of inertia of the circle about its center of gravity. So that is only I have written here. The above equation is the moment of inertia is about an AB line, that is the base of the semicircle. But we need what? We need the moment of inertia of the semicircle about its center of gravity. We have to find out the moment of inertia of this semicircle of its center of gravity. Okay, so semicircular section also can have certain center of gravity, okay, at which the whole weight will be acting. So with respect to that center of gravity, we need to find out the moment of inertia of semicircle. And again, that center of gravity for this semicircular section will be at a distance of 4r by 3 pi from this baseline. If you consider the center of gravity of this semicircle, so that center of gravity will be at a distance of 4r by 3 pi from its base, means here AB line. So which is at a distance of 4r by 3 pi from its base, that is AB line. Okay, so with respect to that distance, we need to find out the moment of inertia of this semicircular section. Okay, for that we need to make use of the theorem of parallel axis. So we already know the theorem of parallel axis equation. So from the theorem of parallel axis, we can write the equation as IAB, that is the parallel line, okay, about which we are going to find out the moment of inertia. That will be equal to the moment of inertia about the center of gravity of that figure plus area of that figure into d square, means here the perpendicular distance between the parallel line AB and the center of gravity of the section we are going to consider. Okay, here for semicircular section, the d means it is the perpendicular distance between the AB line and the center of gravity of the section. So now here we need to find out the moment of inertia of the semicircular section about the center of gravity, which is Ig, we need to find out. So from this equation, so this is the same step I have repeated from the previous slide. So this Ig is equal to, we can write it as Ig is equal to IAB minus area into perpendicular distance square in between the parallel line AB and the center of gravity. Okay, so one by one we try to write. So already we know IAB. IAB means moment of inertia of the semicircle about its baseline. Okay, now that will be equal to half of the moment of inertia of the main circle. So again repeat the same equation, 1 by 2 of pi d power 4 by 64 minus. Again we need to write what is the area of the semicircle. So area of the semicircle also half of the area of the circle. Again we can write it as half into pi d square by 4, we can write it as. And the perpendicular distance already we have written in the previous slide, the distance between the base and the center of gravity is 4r by 3 pi. So into 4r by 3 pi whole square we can write. Okay, so try to modify this equation. So by modifying this equation we'll be getting the required equation, which is 0.11 r power 4. So for modifying, first I would like to make the d in terms of r. So diameter will be equal to, so diameter is equal to 2 times of the radius. So in place of the diameter I want to write 2r, twice of the radius. So same step, half of the, in place of diameter we need to write 2r. Similarly minus half into, in place of diameter in pi d square by 4 we need to write 2r. Already here r is there, so take the square of this 4r by 3 pi will give you 16r square by 9 pi square. Okay, so again modify this equation. 2 power 4 means 16, here 2 power 2 means 4. So by modifying that, try to write the next step. So here 2 became 16, 2 power 4. So r power 4 as it is we need to write minus half of, again 2 square 4 and r square r square. Similarly same step. So by observing this equation here, the pi and pi in the second term, these two pi's can be get cancelled. So 1 pi will be remaining in the denominator of the 16r square by 9 pi square. So try to cancel it. So in the next step we are going to eliminate this pi. So we have eliminated the pi here. So remaining 1 pi is here 9 pi. So again try to cancel the terms. 16 4 ja. Okay, and similarly 4 4 gets cancelled. And again 2 8 ja 16. So again whatever the modified terms after cancelling, write down in the next step half of the, sorry not half, pi r power 4 divided by 4 into 2 8 minus again 8 r square into r square r power 4. So 8 r power 4 by 9 pi we can write. Okay, in this equation we can take the r power as common, r power 4 as common. So take the r power 4 as common, write down the remaining equation, pi by 8 minus 8 by 9 pi. So now we need to take the LCM and we need to modify the equation. So LCM of 8 and 9 pi, it is impossible to find out. So take the product in the denominator. So r power 4 into, in the denominator take 8 into 9 pi, then cross multiply 9 into 9 pi into pi, 9 pi square minus 8 into 8 minus 64. Okay, so by using the calci, try to modify this equation, then automatically we will be getting the value as 0.11. So which is equal to again here 0.11 r power 4, which is the required equation for the semicircular section, and it is the moment of inertia of the semicircle about its center of gravity. Okay, so remember this is the equation of the semicircular section, which will give you the moment of inertia about its center of gravity. Means when the problem is given like try to find out the moment of inertia about the x-axis, means which will be equal to ig only. So ig is equal to, we can write it as 0.11 r power 4. So I hope you understand simple derivation. So here the important thing is you need to remember the formula 0.11 r power 4. So thanks for watching my video. Thank you all.